Your company plans to host a large donation website on Amazon Web Services, AWS. You anticipate a large and undetermined amount of traffic that will create many database rights. To be certain that you do not drop any rights to a database hosted on AWS. Which service should you use? A. Amazon RDS with provisioned IOPS up to the anticipated peak write throughput. B. Amazon Simple Queue Service, SOS, for capturing the writes and draining the queue to write to the database. C. Amazon EOSD Cache to store the writes until the writes are committed to the database. D. Amazon DynamoDB with provisioned write throughput up to the anticipated peak write throughput. Option A, using Amazon RDS with provisioned IOPS, would not be the best choice in this scenario because although RDS can handle a large amount of traffic, it does not have the ability to automatically retry failed writes like SQS does. If the database is unable to handle the incoming traffic, writes could be dropped and potentially lost. Option C, using Amazon Elasticache, would also not be the best choice in this scenario because Elasticache is a caching service, not a message queuing service. It is designed for storing frequently accessed data in memory to improve the performance of applications, not for buffering writes to a database. Option D, using Amazon DynamoDB with provisioned write throughput, would be a good choice in some cases, but it would not be the best choice in this scenario because DynamoDB is a NoSQL database service, not a message queuing service. DynamoDB can handle a large amount of traffic and automatically scales to support the amount of traffic that your application receives, but it does not have the ability to automatically retry failed writes like SQS does. If the database is unable to handle the incoming traffic, writes could be dropped and potentially lost. Additionally, DynamoDB does not offer the same level of control and flexibility for handling sensitive data as a relational database like Amazon RDS does. Option B, using Amazon Simple Queue Service, SQS, is the correct answer to the question. As I mentioned in my previous answer, SQS is a fully managed message queuing service that enables you to decouple and scale microservices, distributed systems, and serverless applications. By using SQS to capture the writes to the database, you can ensure that your application can continue to process requests even if the database is temporarily unavailable or unable to handle the incoming traffic. SQS can buffer the writes to the database and automatically retry failed writes, ensuring that no writes are dropped.